Alright, so I think I'm recording here. Again, I just keep having difficulty with this, and this is kind of time consuming. Sometimes I have to restart my computer, or all of a sudden it'll just stop recording. So let's hope that it gets through this one. We're looking at skill packet number 5 at exponential functions and logarithmic functions, and the first part of this is the exponential functions. And we've been focusing on the graphs of exponential functions in skill 5a, and not only just plotting the points, but also looking at different characteristics of the graph. Is it an increasing function or decreasing function? What's the y-intercept? What's the domain? What's the range? Is there any asymptotes to this? So that's kind of what this one is asking for. So this relies very heavily on our previous skill on our function transformations. And remember, we have this library of functions. We know that the basic exponential function, b to the x, where b is just any base that's positive and not equal to 1, that b to the x has a general shape that looks kind of like this. And we know with properties of exponents that when you plug in 0, that b to the 0 by definition is 1. So this basic exponential function always has a y-intercept here of 1, which has coordinates of 0, 1. If our exponent is positive, and if our base is bigger than 1, then this is an increasing function. So for this problem number 17, this base is actually e to the x, and e is a number that's bigger than 1. E is an irrational number that's approximately 2.718, and that it goes on forever with no repeating pattern. So I know that this guy's an increasing function. So I know this basic parent function, well, all of these in this any exponential function, no matter what the shifts are, it's going to have a domain of all real numbers. So for all of these, for this 17, 18, and I think it was 19 and 20, they're all going to have a domain of all real numbers. So that's going to be the same answer in all of these, because for all of these, you can go to the left as far as you want, and you can go to the right as far as you want, no matter how you reflect it or shift it or do whatever to the transformations to this graph. Now the range here is always going to be dependent upon what you're adding or subtracting. See, this basic parent function right now, I'm not adding or subtracting anything. It has a horizontal asymptote of y equals 0. But when I change that to minus 5, it's going to push this whole graph down 5 units. And 1 minus 5, this guy is now going to be at negative 4. This horizontal asymptote is now going to be at y equals negative 5. And the range of this is going to be, it never touches as negative 5 to infinity. So that's what it's asking for next, right, is the range. So we just found that. Let's put it down here and make it a darker color. With the sun coming in, I can barely see the green, so that wasn't a very wise choice. For y-intercepts, well, it's always the same. For any function, you let x equal 0. You input 0 into the function. So we should get a negative 4, but we know with our knowledge of it shifting down. But if we confirm that by inputting 0 into the function, well, e to the 0, see now, wait a minute, this plus 0, we've changed that with the green there. It's now minus 5. If I have e to the 0 minus 5, well, this e is 2.718, and as long as it's not 0, any base raised to the 0 power is 1, as long as that base is not 0. 0 to the 0 is undefined. So our y-intercept was exactly what we were expecting, that negative 4. So our y-intercept is negative 4. Now the end behavior, okay, so let's write it. So let's erase some of our scratch work over here. And let's shrink this up a little bit. The end behavior, what's happening to the graph when you're far away from the origin? When you move to the left, and very far to the left, as x is approaching negative infinity, what are the y values of this graph doing? Well, the y values of this graph are getting closer and closer to this asymptote, which is the line -5. And what about if you move to the right very far away from the origin? If you move to the right very far away from the origin, this graph is just way up there, so it's heading off to positive infinity. So I think those are all the answers that they wanted. Let's double check. We've got the domain, we've got the range, we've got the y-intercept, and we have the end behavior. So I'll stop here and do the others on another video, so I hope that helps, and I'll talk to you later.